This is EE449 electronic design at Cal Poly. This is our ultrasonic sound sensor project that detects distance or measures distance. And essentially what we have here is a 40 kilohertz sine generator here. It's a crystal oscillator circuit that is paired with an inverter that then creates that signal, which is then sent to a switch, which is then controlled by this 555 timer, which is set up in a monostable one-shot configuration, which is then triggered by this Arduino. And essentially what's happening is that this Arduino is sending a signal, and then it's measuring the time that it takes for a signal to then propagate back to the Arduino, and it's taking that time and it's multiplying it by the speed of sound, and then using an offset to get an accurate measurement. And so once this signal has then been sent, it'll pass this 40 kilohertz sine wave to this gate driver here, which will then amplify it kind of into a square wave, because this is MOSFET based, and then it'll be sent to this transmitter to a surface that it'll ping a sound of 40 kilohertz back to this receiver. This receiver will just take all sound and all noise and take it in. And what we're doing here is we're amplifying it with a capacitor to get rid of some of that noise. And then to ensure that we get the signal, we are then using a phase lock loop that is, surprise, surprise, centered around 40 kilohertz, which would then sends out a pulse back to the Arduino. And so what we can see here with the oscilloscope, because the code needs some work at this time, is that this is the signal that triggers low from the Arduino. And from the time that it's triggered low to the time that we get a signal back from the phase lock loop is essentially 2.8 milliseconds. So 2.8 milliseconds times the speed of sound is going to be 343 meters per second times 2.84 milliseconds, which is roughly 1 meter. But we have to divide it by 2 because it takes time for something to go there and back. And then that gets us 48 centimeters. And right now we're currently set to 44 centimeters. So we have an offset of 4.7 centimeters right now. And what I have here on my calculator is that it's originally triggered at 2.68 milliseconds, which is a more accurate reading. I think that gets us around to 45 centimeters. But the Arduino will only be able to trigger here. And you'll notice that the current problem that we have remaining is that the voltage is 5.7 volts, which is too big for the Arduino. It needs to be 3.3 volts and lower for it to essentially interpret this digital signal. But that is the ultrasonic sound sensor in a nutshell. And eventually we will be able to replace this power supply with a 9-volt bat, and it will run temporarily with however much juice this 9-volt battery can give us. Thank you for watching.